In this video, we are going to talk about section 3.4, which is the derivative. So derivative is a huge topic in Math 121. We will spend pretty much chapter 2, chapter 3, and chapter 4 on the derivative. So big chunk of section is going to be on topics of derivatives. So we want to spend a good amount of time knowing the definition of a derivative and then how to find the derivative. So in this section, we're going to learn how to find the first derivative function using the four-step process, which is using a formal definition. So what is a derivative? Derivative can be described as a rate of change. And if you recall from algebra, when we talked about rate of change, that has to do with the slope. So derivative is actually a little extension of finding a slope. So you can kind of see that slope function here, average rate of change, y2 minus y1, x2 minus x1, different x value on the denominator and different y value. So it's another word for finding a slope. So first, average rate of change. Average rate of change from x of a to x of a plus h is defined as the following. And then we have an instantaneous rate of change. Now, instantaneous rate of change is the change in the rate at a particular instant. And it is the same as the change in the derivative value at a specific point. So we are going to be using a limit definition of our average rate. So basically, you take the average rate of change and take the limit. That will be your instantaneous rate. And finally, we are going to be using the four-step procedure to find a first derivative, which is nothing different than the instantaneous rate of change here. So we break down these procedure into four steps to help you find the instantaneous rate of change, also known as the first derivative. So let's work on a few exercises on how to find the derivative. So starting with number 1. So we have two problems, and then third problem will be like an application problem. So first one, we have problem 1 and 2. Use the four-step procedure to find this notation over here is first derivative. You're going to see later chapter double prime, then this will be second derivative. So the prime indicates the number of derivatives. So there's only one, so it will be first derivative, second derivative, and also you can continue and take the derivative as much as you like. And then notice the symbol here. This is not f prime of 1. It's not f of 1, it's f prime of 1. And this is not f of 2, but f prime of 2. So you're going to be plugging in 1 into the derivative function, 2 into the derivative function, and then 3 into the derivative function, not on the actual function. So let's start with finding the derivative using the four-step procedure. Where is the four-step procedure? Right there. I'm going to do a little bit of a screenshot. And then let's erase this one. Put it right over here so I am reminded what the four-step is. So this is how to find the derivative using the four-step right there. So let's start with the step 1. Step 1 says I need to find f of x plus h. So instead of x, I'm going to be replacing wherever you see x as x plus 1. So it will be 9 parentheses x plus h plus 4. So distributing and combining like terms. So I have 9x plus 9h plus 4. And that will be my step 1. Step 2 says I need to find f of x plus h, take away f of x. Well, f of x plus h, I found it in step 1, so I'm going to substitute this whole thing as this. And f of x, I have it over here as 9x plus 4. So this whole thing. So I'm going to subtract those two functions. So f of x plus h is 9x plus 9h plus 4. Subtract f of x will be 9x plus 4. Notice that I put the parentheses because you want to subtract both terms. If you miss the parentheses, you're gonna forget to distribute the negative, which is very important. So I have 9x plus 9h plus 4 minus 9x plus 4. So 9x cancels out. I have 9h and then add 4. Oops, I made a mistake here. Should be negative 4 because positive times negative is negative. And then this one actually cancels out. So we have just the 9h. Step 3, they want you to find f of x plus h minus f of x all over h. So this one on the top is basically step 2 answer. So that will be 9h on the top divided by h. Cancel out, I have 9. Step 4 will be finding the limit of this function here. So limit of h plus 0, f of x plus h minus f of x all over h, which is this answer here. So that is to find the limit of h goes to 0 of 9. Well, this is a constant function, so my limit will be 9. So what does that mean? That means f prime of x, you just found a derivative of function, which is rate of change, instantaneous rate of change is 9. So that leaves us, since this is a constant, f prime of 1 will be 9, f prime of 2 will be also 9, and f prime of 3 will be also 9. So this will be my final answer here. Okay, so as long as you follow the 4 steps, it will be very easy to find the derivative. It will give you a step-by-step. So number 1 is a little bit easy because it's a polynomial. So second problem is a little bit more complex. I put an example on the rational function, which is a fraction. So we are going to do the same thing. We are going to find f prime of x, and then f prime of 1, f prime of 2, and then f prime of 3. So pulling out those 4 steps, I'm gonna put it on the side here as a reference, and let's begin with finding the f of f prime of x. So step 1, f of x plus h. So wherever you see x, I'm gonna replace it with x plus h. So I have 2 times x plus h all over x plus h minus 5. Distributing the 2, I have 2x plus 2h all over x plus h minus 5. And that's it. I cannot reduce anything, so f of x plus h is 2x plus 2h all over x plus h minus 5. Step 2. F of x plus h minus f of x. So it will be this function, which is over here. Take away f of x. Okay, so let's replace that. So this will be 2x plus 2h orange term. Subtract the pink term, 2x plus x minus 5. Now, when we are dealing with the fraction, we need to have a common denominator. So I'm going to find the common denominator. So this, I need to multiply x minus 5. And from this, I need to multiply x plus h minus 5. So 2 right? So I'm multiplying this one on the first one and I'm multiplying this one on the second one. So I do the same thing too. I need to multiply x minus 5 onto the top function and then x plus h minus 5 on the second term. So let's simplify. I'm going to distribute this one. So I have 2x squared minus 10x plus 2xh minus 10h on the first one. And then for the bottom one, I'm just gonna leave it not distributive because I already have the bottom one same. You can distribute it, but I can always distribute it later on. Distributing 2x squared plus 2xh minus 10x. Now we have a common denominator. I can subtract all these. So I'm going to end up having 2x squared minus 10x plus 2xh minus 10h minus 2x squared minus 2xh plus 10x all over x plus h minus 5, x minus 5. We are not done yet. Let's simplify. So it's nice. Some of things are canceling out. These are opposites. So I only have negative 10h on the top. And then on the bottom, I have x plus h minus 5 and then x minus 5. And that will be the answer to f of x plus h minus f of x, which is this one over here. So step 3 is whatever I have here, I'm gonna divide it by h. So let me add another page. So step 3 will be f of x plus h minus f of x all over h. So copying down this one over here. Oops. And then let's also put these over here. And then this divided by h is the same concept as multiplying by 1 over h. So, right, dividing by h is the same thing as 1 over h. So I'm going to have negative 10h over x plus 5, x plus h minus 5, x minus 5 times h. Notice h cancels out, so I have nicely a negative 10 all over x plus h minus 5 times x minus 5. So that will be step 3. And step 4 will be finding the limit of this function. So limit as h goes to 0, f of x plus h minus f of x all over h, which is, we found out that this here is this function. So we need to find the limit for that function as h approaches to 0. Okay. All right, so h goes to 0 means this number here changes to 0, right? We are plugging in kind of like 0. So I'm going to have negative 10, x plus 0 minus 5, x minus 5. So negative 10, x minus 5, x minus 5, or x minus 5 squared. So that will be my step 4. So therefore, my f prime of x, the first derivative, is negative 10 over x minus 5 squared. Okay. So using this, let's find out f prime of 1. So that is plug it in 1 wherever you see x in the derivative function. So negative 10 parentheses 1 minus 5 squared. So that is negative 10 over negative 4 squared, which is negative 10 over 16, reduced down to negative 5 over 8. So that will be f prime of 1. Let's do f prime of 2. I'm going to actually resize this one so I can fit everything in one page. F prime of 2 will be same thing. I'm gonna plug it in 2 into this function f prime of x. So I have negative 10 over 2 minus 5 squared, which is negative 10 over negative 3 squared, which is negative 10 over 9. So negative 10 over 9 will be my f prime of 2. F prime of 3 will be negative 10, same thing, 3 minus 5 squared this time. Negative 10 over negative 2 squared, which is negative 10 over 4, which is negative 5 over 2. So these will be my final answer. So first two problem we practice finding the derivative and then finding a value at a given derivative function. So one problem, a nice one, nice and easy one, polynomial function, and another one involve fraction, rational function. And the last one, we are going to end the section with one application problem. So let's take a look at this. The profit in $100 from the sale of X item is given by P of X is equal to X squared plus 5X minus 3. Part A. Find the average rate of change of profit from x equal 2 to x equal 4. Notice the word average rate of change from x equal 2 to x equal 4. So what does that mean? That means I'm only doing this one here. Okay? Not doing the limit yet. So it will be, so I will do a screen capture too or copy down. Okay, so part A. So you're looking for, make sure when you are reading the question, you're looking for a key word because that will help you on how to solve the problem. So that's part A. What is part B? Part B is asking you to find the instantaneous rate of change, right? You see the instantaneous rate of change using the 4-step procedure. So this will be this one over here, the one that we just practiced, part B. This one, I'm gonna have it here. And then part B. And part C is using the equation found in part B, find the instantaneous rate of change when x equal 2. So that means instantaneous change function is f prime, but at 2. So that's what this means over here. Okay, so part C is f prime of 2, and then interpret this. Okay, so let's do that. So part A, since we have a P and X, so I'm going to rewrite the F instead of S, I'm going to have a P. Okay, so in this case, I will have P of A plus H minus P of A all over H. Okay. Oh, I see a little typo. This should be f of a here because you see this one, f of a? Just realized it as I look at the example here. So please fix a typo. That should be a. because x equals a. All right, so let's do that. Your x, this is your a, and this one is a plus h, right? So this is your a, and this is a plus extra to make it 4. So that's what this setup is. You have first number a, and then second x number is a plus h. So my first part will be p of 4 take away p of 2. Okay. In other words, this you can see that a is 2 and then h is also 2 to make it 4. Divided by h will be 2. So that's how you figure out a and h. Even though it's not given, you know that this first number is a and then second number is 2 plus the h. In this case, it will be 2 to make it 4. So f of 4, p of 4. I don't know what p of 4. I have to find out manually. So let's do that. So p of 4 is plug it in 4 into the function. So 4 squared plus 5 times 4 minus 3. So this will give me 16 plus 20 minus 3, which is equal to 33. So my first term is 33. My second term, p of 2, will be 2 squared plus 5 times 2 minus 3, which is equal to 4 squared. 4 plus 10 minus 3. So which is equal to 14 minus 3, 11 divided by 2. So which gives me a 33 minus 11 divided by 2, I get 11. So that's part A, 11. Part B, let's find a instantaneous rate of change. And this we practiced it previous page. So let's begin. So everything, I'm gonna rewrite it. This will be step 1, p of x plus h, right? Instead of f of x plus h, because my letter is p. So that means I'm gonna take this, wherever you see x, I'm going to replace it with x plus h. So I'm gonna replace every single x as a x plus h. So I'm gonna have x plus h squared plus 5 times x plus h minus 3. So I'm gonna skip a step little bit. If you FOIL this first term, you end up having x squared plus 2xh plus h squared plus distributing 5x plus 5h minus 3. So I'm going to end up having, nothing cancels out here, so just x squared plus 2xh plus h squared plus 5x plus 5h minus 3. That will be step 1. Step 2, I have p of x plus h minus p of x. So what I'm doing is I'm gonna subtract this term minus this term here, p of x, right? So p of x, x plus h, subtract whole thing, p of x. So p of x plus h is x squared plus 2xh plus h squared plus 5x plus 5h minus 3. Subtract my p of x, which is x squared plus 5x minus 3. So let's distribute these to get to remove parentheses, and I'm gonna take this one and then move it on the next page. So I have more space to work on. Oops. What is happening here? Let's strange. It's not erasing. Okay, I'll just cross it out with the white pen. There. What's happening? Okay, so it looks good. It works now. So let's continue. So I have x squared plus 2xh plus h squared plus 5x plus 5h minus 3 minus x squared minus 5x plus 3. So things start canceling out. X squared, 5x, and then 3's cancels out. So I am left with just 2xh plus h squared plus 5h for step 2. Okay, step 3. Let me make it small. So step 3, I need to find f p of x plus h minus p of x all over h, which is just this whole thing, right? Mine all over h. So that is 2xh plus h squared plus 5h all over h. Notice that each term I have h, so I can cancel one of them out for each term, end up having 2x plus h plus 5 for step 3. And step 4 is finally taking the limit of this function here. So step 4, limit as h goes to 0, p of x plus h minus p of x all over h, which is limit as h approaches to 0 of 2x plus h plus 5. So h is get replaced with 0. So I'm going to end up having 2x plus 5 as the answer. So therefore, f prime, keep mentioning f, but it should be p. P prime of x is equal to 2x plus 5. Okay. So now let's answer the final question using the equation that we found in part B, which is this one that I boxed right here. Find the instantaneous rate of change when x equal 2. So we're going to plug it in 2 and interpret this result. So p prime of x was 2x plus 5. So p prime of 2 is 2 times 2 plus 5, which is 4 plus 5, 9. So what does this mean? This means that when the second item was sold, because that's what the 2 is, right? X represent number of items. So when the second item was sold, what is it? P, profit. Your profit increase at a rate of 900 per item because it's not a profit function because it's not P of X. It is P prime of X, rate of change. So you have to say your profit is increasing at a rate of $900 per item, not the profit is 900. Profit 900 mean it will be just P of X. But we are plug it into P prime of X, so very important to say increasing at a rate of 900 per item. So let me write that out. Means that when the second item was sold, your profit is increasing at a rate of 900 per item. Okay, and then I'm gonna highlight this phrase here. Your profit is increasing at a rate of 900 per item. That is very important. Okay, that's all the example that I have for 2.4. Work on the homework problems so that you have practice on your own. And then next video, we will go on to 2.5.